Welcome, fourth grade teachers. We know you've got incredibly busy schedules, so we designed this explainer to be your practical, step-by-step roadmap for getting ready to teach Unit 1, Onward We Go. Basically, think of this as your planning period, just distilled into a focused, highly visual guide. We're going to cover everything you need to confidently step into your classroom and lead your kids through their very first science unit of the year. Let's get to it.
Okay, let's dive right into our agenda. We'll be covering Section 1, TEKS and Student Mastery, Section 2, Core Science Concepts, Section 3, Addressing Common Misconceptions, Section 4, Investigations and Modifications, and then we'll wrap it all up with Section 5, Vocabulary and Word Wall.
Section 1, TEKS and Student Mastery. So let's look at the unit TEKS translated into plain English for us. Notice how action-oriented they are? TEKS 4.1b is all about the doing. Your students will be planning and conducting their own descriptive investigations and actually designing engineering solutions. Then TEKS 4.1f focuses on the data, having them construct graphic organizers to collect it all. Moving on, TEKS 4.2a wants them to critically evaluate models, identifying both the advantages and, the limitations of those models. And finally, TEKS 4.4a asks them to look at the big picture, explaining how discoveries and innovations actually impact science and society. Now, you might be wondering, what does mastery of these TEKS actually look like on the ground? Well, by the end of this unit, your fourth graders shouldn't just be reciting facts back to you. Real mastery looks like students independently asking curious questions, safely conducting their own investigations, and actively using that engineering design process. And the really beautiful part, all of this is viewed through the historical lens of paper, specifically how Kai Lund's invention of paper fundamentally impacted science and society by finally allowing us to record and share data.
Section 2, Core Science Concepts.
Let's move to and see how this all builds into the engineering design process, which you're going to introduce on day 5. The absolute most important thing to convey to your students here is that this isn't some straight one-and-done line. It's a repeatable cycle. Engineers identify a problem, brainstorm a solution, make a plan, build a prototype, test it, and then, crucially, they improve it based on criteria. And remember, those criteria are just the specific conditions that absolutely must be met for a design to be considered successful. Okay, another major concept you'll introduce this time on day 2 is the CER framework. That's claim, evidence, reasoning. Your students are going to use this all year long to make scientific arguments. So a claim is simply the direct answer to their guiding question, right? It's more than just a yes or no. The evidence is the specific hard data or observations they actually gathered during their investigation. And then the reasoning is the why. It shows exactly how that evidence supports the claim, usually pulling from readings or videos you've gone over. Honestly, I highly recommend posting a permanent CER anchor chart in your room because you're going to refer back to this constantly. Now, notice how we're expanding the definition of models for our fourth graders here. On day 6, you'll teach them that models aren't just physical things like globes or terrariums. They can be conceptual, like a food web, or even mathematical, like a graph. But here's the really critical teaching point. Every single model has limitations. A model is, by definition, a simplification, which means there is a strict boundary to what it can actually show us. Teaching them to spot those boundaries is key to mastering TEKS 4.2a.
Section 3, Addressing Common Misconceptions.
So the crucial point here is how we correct these everyday assumptions in the classroom. Students often come in thinking science is just this static, unchanging book of facts. We need to reinforce that science and engineering are actually ongoing processes. They might think models or exact replicas. Well, we need to remind them that they're simplifications with real limitations. They often picture scientists working all alone in a dark lab, right? We need to show them that science is incredibly social. They collaborate, they argue, they discuss. But please pay special attention to this last one. On day 7, you'll find students often confuse a discovery with an innovation. We have to clarify this. A discovery is something observed for the very first time in nature. An innovation, on the other hand, is a brand new human-made solution to a problem. For example, Kai Lund discovered that certain materials made pulp, but the paper itself, that was an innovation.
Section 4, Investigations and Modifications. All right, let's talk about day 4. You'll be running the laser light descriptive investigation. Students will be looking at exactly how light behaves when it interacts with a wall, a white piece of paper, and a mirror. You're going to need to set up some laser pointers and mirrors for this. Because we're using these specific tools, it is absolutely vital that you pre-teach the safety rules for laser pointers before any student even touches the equipment. Once they're safely set up, They'll record their observations in a data table, directly applying what they've learned about collecting solid evidence.
We all know your classrooms are wonderfully diverse, and the great thing is this unit is highly adaptable. For your emerging bilingual students, encourage them to discuss the big idea in their home language first and heavily emphasize those cognates. For instance, point out that phenomena is fenomeno in Spanish. If you have students who struggle with writing, differentiate. Allow them to draw their observations right in their science notebooks instead. Make sure all IAP and 504 accommodations are ready to go for the Day 10 curriculum-based assessment. And hey, for those students ready to fly, extend their learning by adding some real-world engineering design challenges to their plate.
Section 5, Vocabulary and Word Wall. Okay, on day 3, you're going to build your interactive word wall. Please treat this as your exact script to steal. Seriously, don't just put the words up before the kids even arrive. When a vocabulary word naturally comes up in the reading, follow this exact pedagogical flow. First, place the card on the wall. Second, give a really clear, student-friendly definition. Third, share the Spanish cognate if there is one, like impacto. Fourth, perform a total physical response or TPR motion together as a whole class. Fifth, show a real-world object or relevant image. And finally, assign a student to make a visual card for that word. Trust me, this routine makes the vocabulary incredibly sticky for them. And this brilliantly illustrates exactly what we mean. Let's walk through the physical TPR motions you'll use for some key terms. For phenomena, have the kids make binoculars with their hands up to their eyes. For descriptive investigation, have them pretend to observe something and then physically track it with their eyes. Discovery gets a sweeping hand motion like you're revealing something totally new. And impact is a cool ripple motion with their fingers. But definitely don't stop there. Take a real marker and literally draw physical arrows right on your word wall connecting related concepts. Draw an arrow from phenomena to descriptive investigation because, well, phenomena spark investigations. Draw an arrow from discovery to impact. It literally physically maps the science concepts right in their minds. So, as you finalize your lesson plans, I want you to keep this question in mind. How will your students view the world differently once they realize they have the exact same tools as scientists and engineers to discover, investigate, and innovate? You're literally handing them those tools starting on day 1. Thank you so much for your incredible dedication to your students. We really hope this explainer has you feeling fully prepared, organized, and super excited. Have a fantastic, absolutely impactful start to Unit 1.